This is my presentation on cellulosic ethanol, my biofuel of choice. So while conventional ethanol is a first generation biofuel, which is basically made from food crops like corn or sugar cane, cellulosic ethanol is a second generation biofuel, which is made from like non-food plant matter. So such as leaves or stalks or other types of woods. And basically, it's extracted from the cellulose, which is basically the carbohydrate that provides the structure for the plant cell walls. And one great benefit of this is that it does not compete with other food crops. So the source is lignocellulosic biomass. So it can basically come from corn stover, switchgrass, or even those wood chips and waste, sometimes which we see on playgrounds and such. So basically it's sourced from agricultural residues and then dedicated energy crops. So the agricultural residues are just leftovers of different types of plants and other food sources. The dedicated energy crops are basically just such as switchgrass, which is doesn't really provide any benefit for food crops, but they're high yield and therefore they can make lots of those. And so the key benefit of these is that it requires less fertilizer and water and essentially less maintenance for them to produce what they are there to produce compared to food crops such as corn grain. Carbon fixation is basically where all of the feedstocks grow through photosynthesis and they capture CO2 from the atmosphere to create their cellular structure. So basically this chart is a fuel production overview. So basically there's four stages. There's the pre-treatment where the biomass is treated with steam or acid to separate the three main contents of lignin, hemicellulose, and cellulose. Then there's hydrolysis, which is basically where where the enzymes are added to break the complex of chains into more simple monohydrates or fermentable sugars. The third step is fermentation. So this is where the specialized yeast comes in and it consumes the sugars and converts them into ethanol. And then the fourth stage is recovery, where the um, the ethanol is basically separated from the water and the solids that are produced. This is just another overview. The pre-treatment, the hydrolysis, the fermentation. So how we can implement this, basically this biofuel cellulose, ethanol is past the research and development phase, and they actually have several large scale operations throughout the globe. However, the main problem is that it's a very high cost to process the biofuel. So while growing it is not very expensive and low maintenance, the processing of this biofuel is still very expensive, and therefore it's not as popular as it could be due to the high cost of refineries and stuff like that. This also has a high carbon footprint impact. Just the CO2 that's released during the fermentation process um, can obviously harm the environment. However, the benefit is that compared to gasoline, it's still a lot less, almost 16 to 90%. So the economic impact, the positive impacts are that it can create new markets, obviously, more businesses, and it can support the development of new crops, new energy crops, and it can sort of reduce the amount of reliance that we as a nation have on fossil fuels. However, there are negative impacts. Of course, there's always a high cost to everything, but there's a very high cost to sort of implementing refineries for this biofuel. And the costs are still a lot higher than just normal gasoline or corn ethanol. and therefore it's obviously cheaper for people to just buy gasoline or corn ethanol as their energy source. So my analysis is that cellulosic ethanol is a great step towards sort of creating a sustainable source of energy. However, I believe that the costs will have to be reduced for almost any company or people in general to think that it's um, worth using compared to normal gasoline or other normal fossil fuel energy sources. Um, I think that technology wise, we should still continue to look at new and other types of biofuels to see if there's anything cheaper or more cost efficient, and maybe that's something that runs more efficiently in general as an energy source. Um, so the plan of action that I created was to establish 50 to 100 diversified cellulosic biofirm fineries, and this could help optimize sort of the different types of things we can use for cellulosic biofuels. And it could essentially create a challenge to, oh, what company or what biorefinery can create the best um, biofuel in terms of, or the best cellulosic ethanol in terms of production cost and efficiency. And yeah, these are my sources. Thank you so much.